Hello everybody, this is Naveen S. Sapari, Assistant Professor, Department of Mathematics, KLIT, Hubli. In this video we will continue Z transform. So we'll solve some more problems on Z transform. So already we are having formulas of Z transform of cos n theta as well as Z transform of sin n theta. So now we'll solve one more problem. Find Z transform of sine of 3n plus 5. So finding Z transform of sine of 3n plus 5. Obviously, before applying a Z transform, we try to apply some trigonometric formulas and try to reduce this problem into the standard form of Z transform. So we apply the formula sine A plus B. So here Z transform of sine A plus B is nothing but sine 3n. I will write it as n3 into cos of 5 plus cos of n3 into sine of 5. So now we can write the Z transform, and since we know that here cos phi and here sin phi both are constants, so therefore we keep those functions as it is and only write the Z transform of sin n3 and cos n3. We can compare this with sin n theta and cos n theta. Obviously in both theta is 3. So writing the formula cos phi I will keep as it is as a constant, and Z transform of sin n3 will be Z into sin theta, but here theta is 3 divided by Z square minus 2Z into cos theta. Theta is again 3 plus 1. Similarly plus sin phi as it is, and cos n3 again comparing with the cos n theta. Theta is 3, so we have here Z square minus Z into cos of 3 whole divided by Z square minus 2 times of Z into cos 3 plus 1. So this is the Z transform of cos n3, and hence that's the solution. Let us take the next problem. Find Z transform of cos h of n pi by 2 plus theta. Finding Z transform of cos h of n pi by 2 plus theta. So obviously it is a hyperbolic function, and definitely we don't have the standard form, so we need to reduce this problem into the standard form. And since we have some basic properties, that is cos h n theta can be written as e raised to n theta plus e raised to minus n theta divided by 2. So the same formula I am going to use here. So this can be written as 1 by 2. Obviously first I will take Z transform. 1 by 2, obviously it is outside, then e raised to n theta plus e raised to minus n theta means e raised to n pi by 2 plus theta plus e raised to minus of n pi by 2 plus theta. Bracket complete. So I am reducing this function into the standard form so that easily I can get the Z transform. So 1 by 2 as it is. Now I am going to simplify. So it is Z transform of this e raised to n pi by 2 plus theta can be written as e raised to n pi by 2 into e raised to theta. Similarly here also e raised to minus n into pi by 2 into e raised to minus theta. Simplifying it further, so it is 1 by 2 as it is. Z transform of e raised to theta will be considered as a constant because we take n as a variable, so theta will be constant, into e raised to pi by 2 raised to n plus e raised to minus theta is a constant, and again this can be written as e raised to minus pi by 2 raised to n, just using the laws of indices. So e raised to n pi by 2 can be written as e raised to pi by 2 the whole raised to n. In a similar way, e raised to minus n pi by 2 can be written as e raised to minus pi by 2 the whole raised to n. Now next step, 1 by 2 as it is. Obviously e raised to theta will be constant. Now writing the z transform of e raised to pi by 2 the whole raised to n. Obviously we can compare this with k raised to n. Z transform of k raised to n will be z divided by z minus k, but in place of k we are having e raised to pi by 2. Therefore we have z divided by z minus k, that is e raised to pi by 2, plus e raised to minus I theta, e raised to minus theta as it is. Then e raised to minus pi by 2 the whole raised to n, again comparing with k raised to n, it becomes z divided by z minus of e raised to minus pi by 2. So simplifying it further, we have 1 by 2 as it is into bracket z into e raised to theta divided by z minus e raised to pi by 2 plus z into e raised to minus theta divided by z minus of e raised to minus pi by 2. The next step will be 1 by 2 as it is, taking LCM. Obviously LCM will be z minus e raised to pi by 2 into z minus e raised to minus pi by 2. Now just cross multiplying, we have z into e raised to theta into bracket z minus of e raised to minus pi by 2 plus z into e raised to theta, z into e raised to minus theta into z minus of e raised to pi by 2. Bracket complete. Simplifying here, 1 by 2 into bracket multiplying, we have z into, it is z square into e raised to theta minus z into e raised to theta into e raised to minus pi by 2 plus z square into e raised to minus theta, then minus z into e raised to minus theta into e raised to minus pi by 2, whole divided by multiplying the denominator also, z into z is z square minus z into e raised to minus pi by 2 minus z into e raised to plus pi by 2 plus e raised to pi by 2 into e raised to minus pi by 2 will be 1 here. Simplifying it further, 1 by 2 into bracket. So obviously from the first and third term we are having z square common, so inside the bracket it will be e raised to theta plus e raised to minus theta. And again from the second and fourth term, from the second and fourth term, obviously here e raised to minus theta into, here we are having plus pi by 2. So we don't have any common, just we are having minus z common, so inside the bracket it will be e raised to theta into into e raised to minus pi by 2, and here minus into minus plus e raised to minus theta into e raised to pi by 2 whole divided by z square. So here from the second and fourth term we are having minus z common. So remaining is e raised to pi by 2 plus e raised to minus pi by 2 plus 1. So simplifying further, we have 1 by 2 into bracket. Obviously e raised to theta plus e raised to minus theta will be cos h theta. So we have, it is 2 times of cos h theta into z square minus z into these terms as it is e raised to theta minus pi by 2, it's in power, and here plus e raised to minus of theta minus pi by 2 whole divided by z square minus, again e raised to pi by 2 plus e raised to minus pi by 2 will be cos h of pi by 2. So it is 2 times of z into cos of h of pi by 2. It is 2 times of cos h pi by 2 plus 1. So finally we write it as 1 by 2 into bracket 2 times of z square into cos h theta minus, again these two, e raised to theta minus pi by 2 plus e raised to minus of theta minus pi by 2 will be cos h of theta minus pi by 2. Therefore it is 2 times of z into cos h of theta minus pi by 2 whole divided by z square minus 2z into cos h of pi by 2 plus 1, and hence this represents the z transform of cos h of n pi by 2 plus theta, hence the